Every single day, a truly staggering amount of data is collected about our planet from above. We've got satellites, drones, aircraft. They're all constantly observing, measuring, and recording. But how do we turn that absolute fire hose of raw information, that blizzard of pixels, into something we can actually understand and, use? That is the challenge we're unpacking today.
Okay, so here's our game plan. We're going to start with that big picture, the view from above, and then we'll get into what spatial data actually is. From there, we'll follow its journey from raw collection to real insight, see how it leads to huge real-world decisions, and finally, we'll wrap up with why this whole management process is so incredibly critical.
So let's just set the stage for a second. Think about the sheer scale of what we're talking about here. I love this way of thinking about it. It's like our planet is writing its own digital diary. It's a constant second-by-second record of our world's changes. From shifting coastlines and sprawling cities to the health of our forests. Every little thing, every change is being captured. But here's the catch, right? This diary isn't written in English. It's written in the raw language of data points and pixels. On its own, it's pretty much just noise. To get to the actual story, we need a system, a kind of translator, to manage it all and give it meaning.
And that brings us right to the hero of our story, the data itself. So what are we actually talking about when we say spatial data?
At its core, it's really any piece of information that's tied to a specific place on Earth. The really important thing to remember is that it has three key ingredients. It tells you where something is, its location, it tells you what it looks like, its shape, and, crucially, it tells you how it relates to all the other stuff around it.
And this data comes in a ton of different flavors. We've got the satellite and aerial photos we all know. But there are also things like digital elevation models, which map out the height of the terrain, the hills and valleys, or thermal images that show heat. There's even multispectral data, which is amazing. It captures light way beyond what our own eyes can see, which can reveal things like the health of crops. Each one is just a different lens for reading our planet's diary.
So how do we get from a raw satellite image to, say, a useful map that helps somebody make a big decision? Well, let's walk through this whole data management journey to see how it all fits together. The journey really starts with the fundamentals. First, obviously, you collect the data from all those sources up in the sky. Then you have to store it, and we are talking about mind-boggling amounts of information. Next up, it needs to be organized. And this is more than just putting files in neat folders. It's about building a system so you can actually find things later. And finally, you pre-process it, which is basically a fancy way of saying you clean up any distortions or errors to make sure the data is spot on.
Now we have to talk about metadata for a second. This is the absolute unsung hero of data management. Seriously, the best way to think of it is like an ID card for every single piece of data. Without that metadata telling you when an image was taken, what sensor took it, its exact coordinates, that image is practically useless. It's the key that makes a whole sea of data searchable. Okay, once that data is all prepped and tagged, the journey continues. You start integrating it with other kinds of information. You build systems so you can pull it up quickly when you need it. And because the world is always changing, you have to constantly update your database with new imagery. And then, finally, after all that work, you get to the analysis, the part where you actually start answering the big questions.
This slide here really shows the power of integration. A satellite image of a city on its own is pretty useful. But when you start layering it with data on road networks, and then population density, and then maybe property lines, you suddenly have this incredibly powerful tool for urban planning. Each new layer adds a whole new dimension of understanding. It's awesome.
So, we've walked the journey of the pixel. But what's the payoff? Why go through all this trouble? This is where it gets really, really important.
This managed data, it's the backbone for critical decisions that affect all of our lives. When it comes to disaster management, it helps first responders map wildfire perimeters in real time so they can plan evacuations. It lets cities plan for growth in a smart way by actually seeing where development is happening. We use it to track deforestation, to help farmers keep an eye on crop health, and to manage our precious water resources. This is where pixels literally become policy.
So this quote here really just nails it. All that incredible potential from that eye in the sky is basically locked away without a systematic process to handle it. Good management is the key that unlocks all the value in that data. It's that simple. All right, let's bring it all home. We've seen the what and the how, so let's just focus for a minute on the why. Why does this invisible framework matter so much?
Ultimately, this is what it all comes down to. Spatial data management is the bridge that takes us from raw, chaotic data to clear, actionable knowledge. It's the disciplined, systematic process that lets us read our planet's diary and actually use its lessons to build a better future. And that leaves us with a pretty fascinating thought to end on. Our sensors are getting more powerful by the day, our data streams are getting richer, that diary is being written in ever finer detail. So the question for the future isn't just about what we can see, but what new, incredible questions we'll learn to ask and answer with this amazing power.